All right, so everybody should have completed all 3 trials of all 3 experiments, correct? All right, so I want you, on your prediction, I want to see some type of graph, whether you choose to do a dot plot or a histogram or what have you. We want to see what this distribution is going to look like. So I want you to make a prediction first, and I also want you to make predictions as far as where you think the mean and the median would be. While you guys are working on those predictions, I'm going to take these values, I'm going to enter them into that Statlet, and we're going to see what these distributions actually look like, okay? So work on your predictions while I get these up and running. All right, so up on my screen, this is our class's distribution of the penny tosses. We had 9 people that rolled a 1, 7 people that rolled, or 7 trials that resulted in a 2, 10 that resulted in a 3, 13 that resulted in a 4, and then 9 for both 5 and 6. So it was 9, 7, 10, 13, 9, 9 was our actual data. And I've kind of shown it in a histogram as opposed to a... So when we're looking at data from like a die roll, if we were to repeat this, maybe I had each of you guys do this 10 more times each and collect that data, the more trials we have, the more we're going to see these bars kind of level off. Do you see how these 3 already had the same frequency? We would see that happen, and eventually all of these would have the same heights to them. This would be from 0 to 1, and 2, 3, 4, 5, and 6. Actually, I need to scoot that back here. There we go. And what we would see is that however many trials we had, the height of that bar is going to be 1 whatever. I'll write that down more formally on your sheet here in just a moment. This is what's called a uniform distribution. Uniform distribution here. Where would you predict the mean for this data to be? Probably right there in the 3. The more trials we get, we're going to get a mean of 3 and probably a median of 3 as well, because we have this symmetric distribution. So I'm going to go back to what your page looks like. Right here, so on our actual data, here's what I would sketch in here. Ours didn't come out to look exactly like this, and if you drew what our class data looked like here, that is fine. But we're going to see this come over like this here. 1, 2, hold on, this would be 6 over here. So 1, 2, 3, 4, 5, 6, and we would expect 1/6 of all of the results to come from each of these values. This is an example of a density curve. The area underneath the whole thing, underneath a density curve, our area is always going to be equal to 1. And we call this a uniform distribution. We want to look at this penny toss data next. It's going to take me a moment to get that put in. If you didn't already have your prediction for the penny toss drawn, please go ahead and do that, as well as predictions for mean and median on our penny toss. Okay, so for our next one, looking at the distance of the penny, I thought this was really interesting. That's what our data looks like. What stands out to you about this data? Just looking at it.
0 to 20.
Yep.
A lot of people got really close.
I mean, not 0.
Yeah, like reasonably close. This one goes from 0 to 50. It looks like the majority of people were landing in that range from 0 to 50. From 50 to 100, we had a nice little bump there, and then it kind of trails off to the edge. What would you call this distribution?
Skewed to the right.
Skewed to the right, yes. And I'm going to look at our summary statistics down here. The mean is 53.896. So our mean is right about here. And that would be centimeters. And our median was 37.5. So the median was much closer to here. .5 centimeters. Get a sketch of this on your page, and I want you to mark the mean and the median there as well. While you guys are sketching that and marking your mean and median, I will get our next distribution up. All right. So our last one looks like this. There is our stopwatch. If I asked you to describe this distribution, it is approximately what? Approximately symmetric. It looks like there's a slightly more tail off to the left than there is off to the right, but not enough that I would say it's skewed one way or the other. This has an approximately symmetric shape to it. Our mean is 4.994. .994 seconds. As a group, did we do a decent job of stopping right at 5 seconds?
Yes.
Yes, ma'am.
So what would make it like more skewed and the middle part was a little bit down more?
Honestly, even if that middle part was lower, I would still describe this as approximately symmetric. In order to describe it as skewed, I would want to see something more like our penny toss. That was definitely skewed. We had this big bump of data towards the front, and then that tail that trailed off to the side. Yes. Our median for this was 4.99. So our mean and our median were so close together, it's not even funny. When we have skewed right data, like with the penny toss, what did you notice about the mean versus the median? Which one was larger?
The mean.
The mean was larger. We had a tail off into those larger values, and so that pulled the mean higher than the middle value. This guy right here, when we say he's approximately symmetric, and it is bell-shaped, we say that this is approximately normal. Approximately normal. A normal curve is a symmetric bell-shaped curve, or an approximately symmetric bell-shaped curve. A true normal curve is perfectly symmetric if our data has that approximate shape, so we see our big bump of data in the middle, and we see tails off to either side that are roughly the same size. We're going to say that this is approximately normal. And approximately normal distributions are going to be a really big deal. We're going to find that a lot of different things, when you look at large groups of data, these fall into approximately normal distributions, like people's heights. People's heights have an approximately normal distribution. Some people are much shorter than average, some people are much taller, but there's not as many people that are much shorter or much taller than the average. Most people are going to fall in this middle section. All right. I want to look down at the bottom part of your page where it has a normal curve sketched for us. So let me go back so that I'm looking at the same thing that you are. Right down here. So when we move one standard deviation away, we mark those out, and we go out to 3 standard deviations. We're labeling this with 1, 2, and 3 standard deviations. So for this particular distribution, mu, our mean, for all practical purposes was 5. 4.99, that is a mean of 5. And then my standard deviation, we use this symbol, sigma, to signify standard deviation, about 0.18. So as I'm moving this way, we add 0.18 for each of those lines. Going this way, we are subtracting. With my mean right in the center. This is my mean. On a normal distribution, 68% of all of the data is going to be contained within the boundaries of 1 standard deviation on either side. 95% of all of the data collected will fall within 2 standard deviations of either side of the mean. And 99.7, so darn near all of it, is falling within 3 standard deviations away from the mean. How much did we say was falling within 2 standard deviations? 95%. What percentage of data is farther than 2 standard deviations away from the mean?
68.
Close. I want farther, so I'm looking at this over here together with this over here.
3.
5. Why 5?
2 and 3.
Close. The whole thing together adds up to what percent? 100%. Minus those 2 standard deviations containing 95% of all of my data, so those outward little tail pieces only contain 5% of all of the data. How much of the data would be contained above 1 standard deviation? Close. 50% would be from here over. So this much right here is 68, right?
Yeah.
68. And then we've got this little bit right here and this little bit that we have to include. 16%, yes. I've got 50% that would be the halfway point, plus 34%, and I do 100% minus that.
How you get 34?
I will show you. From here to here, this space right here is 68%. So if I looked at just this part of it, how much would that be?
34.
That's where the 34 came from.
Wow.
If I'm looking at just 1 standard deviation above the mean, that would be 34%. If I go 1 standard deviation above and below, that gives me 68%. What percent of the data would be between -1 for a z-score and +2? Where would I be looking? Where would negative 1 be?
4.82.
Yes. Here's going down to negative 1. Up to positive 2 would be this one. And this little bit.
I see.
How much would that give me all together there?
About 7.
Very close. It's actually 81.5. 81.5%. 81.5. So we included all of this 68, right? 95 minus 68%, and then I would have to cut that in half because that would give me the two sides. So I do 68% plus, was that 30, 27? Yes, 27 divided by 2, which gives me 13.5. So that's how I got that. All right. Guys, your 2.1 homework is due tonight. If you don't know how to do that, please let me know. I will pass out your 2.2 homework tomorrow. I have your tests graded. They're in Canvas. I haven't been able to pass them back yet, though, because not everyone has taken them. I have not yet updated the homework grades. If you got a 70 or higher, your homework grades will go to 100%. I will do that at the same time that things migrate over to Skyward. Have a fantastic rest of your day, guys.